The School of Aquaponics. Brooklyn, St. Michael with the School of Aquaponics. This is the first lecture in the Botany for Aquaponic Growers section that we're going to have going on. We're just going to get into a lot of plant biology, so you'll be able to understand a lot of the processes that's going on when the plants are developing. What's pretty much what's going on the micro level behind the scenes of plant development. So that's what we're going to touch on. I'm super pumped to get into this these lectures so we can kind of get a better understanding. We want to be well-rounded in this aquaponic game, and that entails a lot of different subject areas, and plant biology is definitely one of those. So we're going to start off the first lecture discussing the scientific method, because the scientific method is basically just going to give you a scope pretty much to look forward in, so you can understand how a lot of these plant scientists are coming up with a lot of the conclusions that they're reaching, how a lot of these discoveries are being made, and just pretty much how science works in general. So the scientific method will give us a great deal of information for those of you that are unaware, and then from there you'll be able to understand a lot of the the further lectures that will come down the line. So let's get started with the scientific method. But before we get into the scientific method, let's kind of go back and kind of delve into some of these other I guess you would call them ways of discovering truths that came before the scientific method and that led up to the scientific method. So the first one that we're going to discuss is the religious method. This is the first way pretty much that the earliest humans, well, maybe not the earliest humans, but humans prior to the 15th century, this is pretty much how they came to conclusions on a lot of the phenomenon that they were seeing out there in the world, a lot of the events taking place. It was from a religious perspective. And what this pretty much entails is attributing a god to any of the phenomenon that occurs. So let's say, for instance, we had a whole field full of crops, and then maybe one day they all were destroyed. Maybe they were infested by some locusts, and then they all were destroyed. Someone would come along and say, oh, I had a revelation, or I was told by X deity that the reason why this occurred was because you did this, or because you didn't do this, or any other mixture of variables that you can add in there to explain why that event occurred. And that would be what was acceptable during that time. But the problem with doing it this way, or trying to find truth and verification through this method, is that it's not consistent. It doesn't offer any type of consistency, and there's really no correlation between an action from someone doing an action and someone having a revelation and another separate event occurring. So if, for instance, in this case, say if the guy ate a food that he wasn't supposed to eat, the guy with the revelation came and said, well, because you ate that food, all your crops got destroyed. The deity told me because you ate that food, all the crops got destroyed. Now, if he went and ate the food again, and a lot of times nothing's going to happen, then it's not consistent. But if he were to go back and eat the same food, then the guy with the revelation came back and said, your crops are going to get destroyed. And every time they got destroyed, now we're on to something. You see, now we can have some, it's consistent. Now we can say, okay, maybe there is a correlation between the eating the food and the deity saying something and the crops being damaged. But since humans have been on Earth, no one has found any type of correlation that is consistent in that type of manner. And because you can always have someone come up, another person who has a revelation, and they can say that the reason why the crops failed is because of another reason. So, and there's an endless amount of people that can come with their revelation. And when it's that subjective, you don't really get any universal truths. It's pretty much impossible to get any universal truths doing it that way. So that's why that way isn't as effective now. And you'll know this too, because if you went to the hospital and they said, and you were having pains or aches or whatever, you're going to want them to use some type of instrument to actually measure it. You're not going to accept if the doctor said, well, you're having this pain because X deity told me that. You would probably be trying to pull out a lawsuit or something crazy like that. So, it just doesn't work on these type of levels when you're trying to get to some absolute truth. They don't work that way. For your own personal beliefs and stuff like that, then that's fine, but not in these type of areas. And people have to learn to distinguish between the two. and not mix them together because it won't work. So from there we have the religious a method that was taking place before the 15th century. So around the 14th century, that's when we start getting introduced to a different type of outlook on the world and trying to figure out how things work. And this was made, it made popular by the Greeks, but I'm sure that it was going on prior to the Greeks, but they pretty much popularized speculative philosophy. And what speculative philosophy is pretty much analyzing the world logically. This is when, you're using a lot of your logic, you're piecing things together logically, but you're not running any tests. So for instance, you'll see something like you'll walk down the street. This is back in the 15th century. You're walking down the street and you see that the street is flat. And everywhere you walk, you see that, pretty much the road or wherever you're at is pretty much flat. So your assumption, logically, you would assume that the earth is pretty much flat. And this was something that was very popular back then. It made sense. Logically, it makes sense. You'll say, okay, everything is flat. When I walk this flat, the earth has to be flat. There's no way it's any other shape. It doesn't make any sense logically. So that is one way. And we can see the issue with that because now we know that the earth is not flat. But also there's times where people would get it right. Speculative philosophy, because a lot of the things that we think of logically, they are correct. But just as many things that we think of logically are incorrect. So this is one of the problems with that. So logically, another example would be from a gentleman named Democritus. Well, he was around 400 BCE. His observation led him to believe that objects could, you can keep breaking down objects, but eventually you're going to get to a point where you can't split an object up anymore. So that was his logical conclusion that he came up with, but he didn't run any tests. So there's no way of actually verifying it. Logically, it sounds good. So now we can test that today and we can find out, what he was referring to is an atom, or what he logically thought was correct. It is correct, and it's known as an atom. So we can see how speculative philosophy, it can work on both ways. You can either be correct or you can be incorrect. And a lot of times when you're doing this logical analysis of things, there's other people don't think the same way you think. So you might think one thing is like different cultures. One thing is logical in one culture, but if you go to another culture, you can look at the same exact thing and they have a totally different perspective on what you guys are both looking at. So that is where the problem comes in. You have too many different options, too many different choices, too many different alternative conclusions, and there's no one that we can say is for sure. And this is where the majority of people, well, I won't say the majority, a great deal of people's mind is still in this form of thinking, in the speculative philosophy thinking. And it makes a lot of tension between scientists who are actually proving things or giving the best effort to prove something versus people who are just, going about things logically. So there's a tension between these two type of people, which is why you see a lot of times when science will show something, then you have a group of people who are against it. With things like GMO, vaccines, all type of things, where you have people who are just basing their logic and pretty much basing their information and their conclusion off of logic versus reasonable testing, something that can be duplicated and shown to be proven to work. So this is kind of the battle in today's time. So pretty much it's fine to have a logical conclusion, but it really doesn't mean much without testing, which brings us to the scientific method, which emerged around the 1400s, probably a little bit prior to the 1400s, but somewhere around there it started to gain popularity. And it's pretty much just was a new way to analyze facts, way to analyze the world, way to come up with conclusions that can stick, that are pretty much indisputable, and that it can be universal and applied and used by a variety of people, no matter what background they come from or anything like that. But there's pretty much a few fundamental tenets that are established when dealing with the scientific method, and they have to meet these tenets in order to even qualify, or else it can't be used in the scientific method. So the first of these tenets is the source of information. There's guidelines on where the source of information can come from. The source of information has to come from something that is carefully documented and in a controlled observation or an experiment. It has to come from something like that. It can't come from the priest, the pastor, or even the scientist himself. Meaning things that we're unsure or don't have much information on and don't have conclusions and theories on, like dark matter and parts of black holes, things that we're just not all the way sure about. I don't want to hear from the scientist coming on telling me this is what it is. I don't care what title he has. Where's the test? That's what I want to know. Where's the test? You can't just come. You see, it stops people from doing that. Same thing with the priests and pastors. I don't want to hear about no revelation that you had about what explains the dark matter. That's not doing me any good. Sounds good. It's not working at all. I don't care about none of the titles. I want to see the experiments. From there, we can go on. See, that's why I like this, because a lot of times back in the day, way back in the day, if someone had a lot of status, they would be able to pull those type of things on the common people. Oh, well, I'm going to explain. Since I have a lot of status, I'm going to say this is what it is, and everyone else is just going to have to accept it. No, 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 no. This stops people from doing that. This stops people from doing that right here. So this is one of the things why you'll appreciate the scientific method as we continue going on. So a lot of the claims, it can come from, that's not saying that it can't come from these people. We just have to be able to verify and prove it. That's all it is. It has to be proven. It stops people from doing all that nonsense. Oh, because your skin color is this color, or because your eye and your hair looks like this. It cuts all of that out. Cut it all out. We don't care anything about that. I want to know about the information. That's what this cuts right into. Forget all the status and all that, man. I'm hyped on saying that's why I keep going over this part, because this is very, very beneficial to finding truth. So from there, we have our source of information. Now, too, the second tenet is that the phenomenon, it must be tangible, something that could be seen, felt. It's something along those lines. And there's things that we can't see or feel, like magnetism and neutrons, but we have machines that can detect those reliably. Now, things like ghosts, these are intangible. These cannot be seen or they can't be felt. So, and there's no instrument that has ever reliably detected a ghost. So if a ghost does exist, it has to be intangible. And now we can't, there's no scientific method that can verify that. That's something totally different. That's outside of the scope of the scientific method. So we have to understand that. And I'm not talking about using the infrared meters that you see and stuff like that on TV. That any reasonable person knows that none of that stuff is legitimate. That they're testing for light and heat and infrared, and then when something reads on the radar, they're saying that that's a ghost. Well, you're assuming that ghosts have those type of properties. You're already jumping the gun. First, we have to determine if ghosts even have those type of properties to even register on the meters. So, but that's jumping into a totally different subject, but that's outside of the scientific method. So if someone starts talking about that, we can detect ghosts, get out of here. I got to say, get out of here. Now you're jumping back into like speculative philosophy and the other type of ways of coming about truths. And that's not what I'm really concerned with. Not in today's age. I'm not really concerned with that. Now, if it's something that, we can't prove like that, I'm open for subjective thoughts. I'm open for that all day. I'll listen. Oh, that's a nice speculation that you have on that. I'm open for that. But when people try to convert it and say that it's a fact, then that's when it's a problem. So beliefs are open for those type of interpretations, things that we cannot prove. That is totally fine. But for me, once we're able to prove something, then that's when the belief for that particular item or subject is out of the window. That's for me. So we have that. Now, number 3 is consistency. That means we should be able to take the same experiment. Each time we run this experiment, we should be able to get the same results. If we're in the same environment, everything is running the same, the results should be the same every time. You can't go in there because we know that the physical forces are constant. That's one thing that is constant, and this helps us make predictions for future experiments. Like if you're running an experiment, you can't, and maybe your hypothesis is incorrect. You can't go in there and say, well, the water must have changed into something else. We know that water is H2O, and it's always been H2O, and it always will be H2O, and it didn't change just because, or for the 1 second or the 10 minutes you ran your experiment. We don't want to hear that. Nobody wants to hear that. So the physical forces remain constant. The results should remain constant. If something is not constant or consistent in the experiment, the chances are the hypothesis is wrong. Get the heck out of here and go try something else. Don't come in there trying to say that the water changed or evil spirit did this while you push this button. Get the heck out of here. Go try it again. Go figure out another hypothesis and then come back and test. When we're consistent, now we know. Then we know that something is legit, because we know that water is not changing or any of the other physical forces aren't going to change. So there's no miracles or anything like that happening. And it stops people from saying the same thing as the opposite. If something does happen, you run an experiment and something crazy does happen, you won't say that, oh, it's a miracle that it happened. No, the forces remain the same. So therefore, we're able to repeat the process over and over. And that's this. If the forces didn't remain the same, then we wouldn't have things like cars and jets. We wouldn't be able to make those type of things because it wouldn't work. Because the forces would constantly be changing. So you get the point on that. So that's the third tenet in the scientific method. Now, the fourth tenet is skepticism. You have to remain a skeptic and be open-minded and willing to change a conclusion if the evidence presents itself. So there could be something that we can just have a ton of evidence on, but just because we have a ton of supportive evidence on a certain theory, that does not mean that it is the absolute one. It does not mean that, because times change, information changes, and technology increases and allows us to have a wider view of things that are really going on. Like, for example, the current evidence supports that all plants are made up of cells. That's the current evidence right now, and you can pretty much look at pretty much any plant and you will find cells. But if new evidence of some type of other plant comes along and it doesn't have cells, you have to be willing to change the definition or the conclusion. You have to be. You see how honest this is? This is what I appreciate about the scientific method. It's extremely honest. It doesn't get more honest. I mean, how much more can you ask of that? Like, just because you come up with all this evidence does not mean that is what it is, because facts a lot of times and evidence are a lot of times are related or relative to what we have available to come up with the facts. So there may be a different part somewhere in the bottom of the ocean where there is a plant down there or whatever that doesn't need light, and maybe he's not made of cells, maybe he doesn't have, typical things that we think of a plant, and just maybe totally foreign. And when we know about it, we have to change the definition or the way we define a lot of things in that area. So it's just a very honest way of looking at things. And I definitely respect the scientific method. And I'm sure that a lot of you guys out there respect it as well, too, because it's gotten us far and progressive in today's time with technology and just with the comfort of life, depending on overall and everywhere in the world, pretty much. It has attributed to some type of furthering of human life and human comfort on Earth in comparison to the way we lived a long time ago. So it's just a different way of looking at it. So with the scientific method, we have our observation first. You're observing something's catching your eye. From there, you're going to run tests, experiments, and analyze those experiments. Then you'll come up with a hypothesis. So for instance, we see in dark caves that where no light penetrates, we see there's no plants that grow in there. So we run some experiments, and then our hypothesis is that plants must need light to grow. Maybe that's the reason why they're not growing in caves. So then we run more tests, analyze. Maybe we will run some tests with light, low light, plants growing in low light, plants growing in full light, plants growing in no light. We'll see that the vegetables that we grow, specifically in aquaponics, they're all going to require light to grow. They're not growing if it's just in complete darkness. So we can conclude from there. We run repeated tests over and over and over again. You run the test. I run the test. Habib run the test. Joshua runs the test. Dikembe runs the test. It don't matter who runs the test. We're going to come out with the same results. From there, we ran it this many times. Now we have a theory. So it's been tested over and over. And that's how we get a lot of these other theories, like the Big Bang Theory. That has went through this test. All the evidence is pointing to there must have been a period where there was a Big Bang, and that from there, everything else expanded. It's a single point, everything else expanded. All the evidence points that way. Every time we run a test, it points to the Big Bang. It points to the singularity, and that's where it all starts. All of it points there. Nothing else is pointing anywhere else. The Big Bang Theory, it went through the test. The theory of evolution, it's the same exact thing. When it's a theory, a lot of people don't understand. A theory in science is not the same thing as a theory talking to a regular person. It has went through the test. Theory of evolution, theory of the Big Bang Theory, they've all went through that. So that's pretty much where we're at on that. After you ran the strenuous test, now we've come to our conclusion. And that does not mean, like I said, that is the final conclusion. That is what we know as of now. That is the definitive answer as of now. We're going to come up with more technology, and we'll be able to get more explanations on a lot of other things. And it could change, and maybe it doesn't change. But as of now, if you had to bet your bottom dollar on it, you're going with the one that's a theory. If you're a betting man, you're going with the one that's a theory. If you're just someone who's going to wing it, you'll go with whatever you want to go with. So this is pretty much the breakdown on the scientific method. I hope everyone appreciates that and gave you a better understanding if you weren't familiar with the scientific method. And that'll give you just one more thing to think about when you're analyzing information. So this is Brooklyn St. Michael with the School of Aquaponics. Woo!